In this article, an area additive manufacturing framework is presented and evaluated. The approach involves dividing the desired shape into smaller chunks using a search algorithm for the optimal planar cut set and treating each chunk as an independent printing entity. A novel dependency graph mechanism is used for addressing interdependencies and printability constraints while imposing a manufacturing sequence for the chunk's assignment to the UAV. To implement this framework, an aerial hexacopter platform, equipped with a pressurized canister, containing a lightweight expandable foam material is used. The UAV's onboard computer controls the foam extrusion, enabling the UAV to construct its assigned chunk, while traversing through space-filling path and depositing material in layers. An experimental evaluation is carried out for different geometric shapes. A rectangular mesh is printed first with a side of 55 cm and a volume of 13.2 liters. It is decomposed in 8 chunks and 4 cans were used to manufacture it. The whole sequence of the printing procedure is shown in the following video. Initially, the UAV starts deposing the material in order to print the bottom chunk of the dependency graph as shown on the top left. As soon as it is printed, the chunks dependent on it become available to be printed and the one with the most dependencies is selected to be manufactured next. This iterative assignment process continues all the way till the end of the printing. The side view of the printing process captured from a camera close to the platform is shown in the bottom right. The UAV is depositing the material into layers while tracking the manufacturing path for each chunk. The material's extrusion is controlled using a servo and it expands as soon as it comes in contact with the air. It is noticed that the downwash coming from the propellers is affecting the extrusion, influencing the overall performance. The execution is carried out by executing the printing of the chunks sequentially while the UAV is refilled with the available material every time it lands. The hexagonal is wider shape relative to the previous one, requiring extra precision in order to deposit the layers accurately on top of each other in order to maintain proper adhesion. Despite the overall shape is tracked, the influence of the air draft is more noticeable in this configuration. The accuracy of the executed motions in 3D and in an occupancy 2D grid are shown on the left while the final printed meshes after curing are shown on the right.